It is possible to treat ciliary body detachment and hypotony by removing anteriorly located membranes under endoscopic guidance. While there are those that claim that this feat can be achieved through the operating microscope, this assertion seems to be doubtful. With the endoscope tilted upward from the sclerotomy site, a view of the peripheral retina, pars plana, ciliary body, lens, and posterior iris may be obtained. Even if this region could be seen with the operating microscope using scleral depression, this maneuver distorts the abnormal architecture that is present so that the surgeon cannot truly assess the relationships between the membrane and these anterior structures, thereby limiting the potential for success. Here, a straightforward cyclitic membrane is present. Its excision will result in reattachment of the ciliary body and hopefully resumed aqueous production. In this video, a dense membrane overlies the ciliary body and is attached in places to the posterior iris surface and in others to the peripheral retina. At first, an MVR blade is slipped beneath the membrane and is used to elevate or divide it. Once it has been lifted off the ciliary body, the vitrector is used to remove it from the eye. Near the end of the video, an area of membranes is removed and the ciliary body can be observed to spring back to a more anatomic position. In this instance, a panoramic view reveals a diffuse membrane over the ciliary body and posterior iris regions with anterior retraction of the ciliary body. A posterior view indicates a PVR detachment as well. The vitrector is used to create an opening in the membrane that has a brown adhesion to the posterior iris surface. Now there is an opportunity for end-gripping forceps to grab the membrane and pull it off the ciliary body surface and out through the sclerotomy. The ciliary body can be observed to assume a more normal position. An extensive area of subretinal gliosis is then addressed by creating a retinotomy over the band and then pulling on this band, ultimately breaking its connections and allowing it to be retracted through the sclerotomies and out of the eye. The ability to rapidly shift between close-up magnified view and a minified panoramic one is quite useful here. The membrane is so extensive that even though a portion of it has been pulled through the sclerotomy, the posterior aspect of the membrane must be regrasped so that it might all be removed. Then the pre-retinal membranes may be addressed by a similar approach. Air fluid exchange is performed, the retina is flattened, and the retinotomy is lasered in a painting fashion. So let's put it all together. Here is a relatively simple case of a diabetic vitreous hemorrhage. A hazy view is first apparent because the tip of the endoscope is situated within the bloody vitreous. Once the vitrector clears the view, more focal areas of blood adherent to the retinal surface may be addressed. The endoscope is held closely to the retina, creating a magnified view for shaving the blood from the retinal surface. Later, a more panoramic view is established to permit extrusion of blood from the retinal surface and then apply laser. Putting it together in this more complex PVR case, the images on the upper left clearly delineate the relationship between the peripheral apron of contracted vitreous and the stiff retina with breaks. The vitrector is viewed in a panoramic fashion to enable shaving of the vitreous base and judging the mobility of the retina. This represents a unique view of the gliotic membrane on the retinal surface that is more coaxial than top-down. In the upper right video, this magnified coaxial view of the membrane's attachments can be seen. The attachments of this tissue's underside to the retinal surface are visible. This is not possible with the operating microscope. A forceps is then used to grab the edge of the membrane and apply traction. The endoscopic view is alternated from close-up to wide field, continuously indicating to the surgeon whether the membranectomy is proceeding well and may be continued, or whether there are untoward effects of this traction and that it should be discontinued. In the lower left video, the retina is viewed panoramically and is now freely mobile. As air fluid exchange is performed, the panoramic view is maintained. The retina is seen to bulge into the vitreous cavity as a soft-tipped instrument is used to aspirate the vitreous fluid over the optic nerve surface. Then, a pre-existing inferior peripheral retinal brake is used to actively extrude subretinal fluid under panoramic endoscopic guidance. The view is easily shifted from aspirating subretinal fluid through a peripheral brake to a posterior view of aspirating intravitreal cavity fluid over the optic nerve surface. By alternating between these two visual vantage points, the vitreal and subretinal fluid may be rapidly removed from the eye. This would not be possible through the operating microscope, even if anterior segment conditions were not deteriorating at this late stage in the procedure. The video on the lower right is a panoramic view of the final result, with flat retina, gas-filled vitreous cavity, and good laser reaction. Well, that's the end of our tutorial, and I hope that you have found this information so useful that you wish to incorporate endoscopy into your usual surgical routine.